In this lab, we will continue with looking at the biodegradable data analysis. In step 1, we loaded the dataset for biodegradable dataset from the website, and in step 2, we explored the data. And to explore the data, we performed data analysis. To explore the data, we plotted box plot of each of the variables in the data frame. And then we plotted a histogram for each of the variables in the data set. And then we checked for missing values, and there was no missing values. So in this step 3, we will look at feature engineering. Let's try to create some relevant variables. So let's create two new variables, NHM plus NO and NNN plus NCR x3. So create new variables. Biodeg, so we'll create new columns, NHM plus NO equal biodeg, or the NHM column plus NO column, and another new column we'll create is for NNN plus NCR x3, and that equals NNN plus NCR x3. So you can see that now we check the head of the biodeg data frame, and printing the first few lines, we see that the new two columns are created, NHM plus NO and NNN plus NCR N3. Then we will encode the categorical variable class using label int encoder. So encode the class column has integers. So let class underscore encoded column equal s dot integer of the class, and checking the head of biodeg that prints the first few lines, and we can see for the class RB the first 6 rows shows the class is RB and the class encoded is 2. Then we split our data into training and test set. In the following code, we randomly divide the data set into two halves and save them in two data frames named train and test. So number of rows, let's check the number of rows. Let n equal n row of biodeg, index 1056. Let's check the size of the subset. Let n1 equal round n divided by 2. So n divided by 2 is 528. 527.5, and rounding the 527.5, that rounds to 528. Then set random seed, set dot seed of 1 2 3 4 5, sample the subset. Let index equal sample n, and n is n is the number of rows, which is 1055, and we sample n1, and n1 is 528. So let's check the first few lines of this index. The 142, 51, 720, 730, 664, and 826. Then we set the seed over here so that once the values are found, it doesn't find uh, the new indexes. So sample n comma n1 has found this. In the next run, it will be same indexes which are selected. And if we don't set the seed over here, then it will select the new rows, the new indexes. Let train equal biodeg of index, comma, and the space means all those values in that row is selected. And checking the head of the train data set, we get this. And we can see in the first few lines that the index 142, 51, 720, 730, 664, and 826 are selected. Then we check the test data frame. So let test equal biodeg bracket. Now we don't want the indexes to be selected. We want the rows that are not included in the index to be selected. So all other rows are selected over here. Head of test gives us this. So first few lines. Then we perform robust scalar on both train and test feature. So assign features for train and test. Let x underscore train equal train dataset, but bracket, this space means the space means all the rows are selected which does not include the names of the train equal to class, or the names of the train equal to class underscore encoded. So we do not want to apply the scalar on the target data set, class or class underscore encoded. So checking the head, we the first few lines show us that class and class encoded is not selected. Then to apply the pre-processing command, we will import the library caret, C-A-R-A-T, C-A-R-E-T. Then let scalar equal pre-process bracket train, and then bracket, we don't want so break square bracket, and then we will leave this first value as blank, and we'll place a comma, and the second value will be not the exclamation mark, names of train equal to class, or names of train equal to class underscore encoded. So this is the model that we have formed, the scalar model. So this is not using the robust scalar, but this is the default scalar that we are using. Transform, scale, transform or scale the training data. So let x underscore train underscore scaled equal to predict bracket scalar comma train. So we will have all these train data being predicted, but the class in the class encoded columns will not be predicted. So the class and the class encoded column will remain the same. Then we will transform or scale the test data using the same scalar. So we will not create the model in the test data set, but we will only do the prediction. So let x underscore test underscore scaled equal predict bracket. Scalar is the model name, comma test. So this will find the new values for the variables in x test, but except the class or the class encoded. So we can see here the class or the class encoded will not be predicted. They will remain the same. Then we import the library ggplot2, and using ggplot2 we create a scatter plot of scaled NHM versus scaled NCB. So ggplot of x underscore train underscore scale data, comma IES is x equal NHM, comma y equal NCB. So the x-axis will have NHM and the y-axis will show NCB. And these are the scale values. So plus geom underscore point of bracket color equal red. So the points will have color red, comma alpha equal 0.5 plus. So red points with some transparency plus labs. Now labs mean labels. Bracket title equal scale training data, comma x is equal scaled NHM, comma y equal scaled NCB. So this is for setting the labels and title. So we can see as the scaled NHM increases, the scaled NCB also shows kind of the good fit will be scaled NCB shows a decrease, but some of the values are high here. So if we do a good fit, we will see that it's like a cave. It's forming like a cave.